make sure it's not shaking. Okay, so slope is rate of change. Another way you would have seen it described is change in y over change in x when we refer to the graph, as well as rise over run, how fast it's going up and over. And we'll look at that when we go to the workbook as well. The equation for slope, if you're given 2 points, slope is m in equations, and it's y2 minus y1 over x2 minus x1. So again, we'll practice using that equation when we go over to the workbook, and it should be reviewed for you, which is nice. There's also a lesson on Khan Academy for finding the slope, so right after we do the homework, I would recommend going over to Khan Academy and practicing that exact same lesson. All the Khan Academy lessons are aligned with what's going to be on the test on Friday, so I'd recommend using those as a study tool for the test. Okay, another thing you saw in algebra is positive slope happens when you have a line that's increasing to the right or going up to the right. You would get a positive slope, like m equals 4 would be a positive slope. Then negative slope looks like this when your line is going down and to the right. You would get a slope of like -3 or -3 over 2. Zero slope happens when you have no change over time. So it's just a straight line. As time progresses, there's no change in the height of the plant or the distance of your car. You're just not moving as time changes. The equation for something with zero slope would be y equals 2. Or something similar to that, y equals a number. Then undefined slope. What that looks like is just a vertical line. And the equation would be like x equals 3. When we talk about slope in real-world situations, it's usually change over time. As time progresses, your distance or growth is going up or down. Undefined slope doesn't really make sense because time's not change, like time's staying still. So that's why it's such an odd phenomenon. Postulates. There's 2 postulates, or 2 big ideas that we're working with, and again, we'll practice using them on the workbook. But here's the first idea, slopes of parallel lines. Parallel lines have the same slope. Parallel lines have the same slope. And slopes of perpendicular lines. The slopes of perpendicular lines are negative reciprocals, and I'll review what that means in a second. The slopes of perpendicular lines are negative reciprocals. First of all, what the heck is a reciprocal? Reciprocals look like this, reciprocals. If you have 1/2, the reciprocal of that would be 2 over 1, or just 2. Yes, I wrote it like this because technically you're flipping the fraction, but 2 over 1 would just simplify to 2. So 1/2 and 2 are reciprocals, or like 3 and 1/3, because 3 over 1 would flip and become 1/3. But this is negative reciprocals. So an example of this is one line would have a slope of 4, and the other line would have a slope of -1/4. So if you're asked what the slope of a line perpendicular to a line is, you just take the original slope and you flip it and make it negative. And again, we will practice this. I'd like to draw a picture if we can squeeze it in. I'm going to squeeze in a little picture right here. So let's say you have a line, and you have a line perpendicular to it right here. this line right here, the one that's decreasing, would have a negative slope, as we explained up here. So the slope for this might be negative 1/4. It's going down 1/4 each time. Then the slope for this one, the one that's perpendicular to it, the slope would be positive 4, a negative reciprocal of that. And again, we're going to practice this in the workbook. So that is all for the notes on 3-3, so let's transition over to the workbook for lesson 3-3.